2. Interaction between photons and electrons. By considering light as photons, Einstein could explain photoelectric effect. He proposed a theory of photoelectric effect. A. Work function. Electrons in metal are helped by positive metal nuclei, and an electron on the metal surface is helped by less attractive force. The work function of a metal surface is the minimum work done by an electron against the electric attractions due to the positive nuclei when it tries to leave the metal surface. Due to different atomic structure and lattice structure, the work function of different metal surfaces can be very different. When an electron is so lucky to be hit by a photon, the electron absorbs the photon and tries to leave the metal surface. If it absorbs enough energy to leave the metal surface, some energy will be left as kinetic energy. For an electron situated deeper under the metal surface, it has to do more work in order to escape from the surface, and hence, this photoelectron escaped will have a smaller kinetic energy. On the other hand, if the energy of the photon is simply smaller than the work done required, the electron just simply cannot absorb the photon. B. One-to-one interaction. The energy of a photon can only be absorbed by one and only one electron. Alternatively, an electron can only absorb energy from one and only one photon. This is called one-to-one correspondence. C. Threshold frequency. When the energy of photon is smaller than the work function of the metal surface, the electron just cannot absorb the photon. If the frequency of the incident radiation is exactly the threshold frequency of the metal surface, which can just produce photoemission, then the energy of the incident photon is just the work function of the metal surface, and therefore the work function equals H times F log. Example 4. Work function and threshold frequency of sodium. When the energy of incident photon is smaller than the work function of the metal surface, there is no photoelectric effect. Energy expressed in electron volt can be converted to energy in joule by multiplying with 1.6 times 10 to the power negative 19. Remember, all energy units should be consistent in a formula when doing calculation. D. Einstein's photoelectric equation. Now you should have understood the whole process of photoelectric effect. After an electron absorbs the energy of a photon, there is a work done for the electron to escape from the metal surface. The energy left becomes kinetic energy of the photoelectron. Therefore, we have energy of photon equals energy required for electron to escape from metal plus kinetic energy of photoelectron. The minimum work done to escape from the metal is called work function. Thus, we have maximum kinetic energy of photoelectron equals energy of photon minus work function HF minus psi. Thus, the maximum kinetic energy of photoelectron increases with frequency of incident radiation. What about increasing the intensity of light with a fixed frequency? By one-to-one correspondence, it will only increase the number of photons reaching the surface per second. It does not increase the energy of the photoelectrons. In other words, it will increase the photoelectric current only. E. Time delay in photoelectric effect. As an electron can only absorb one and only one incident photon, it is reasonable that there is no time delay for photoemission to occur, even if the intensity of radiation is extremely low. Example 5. maximum kinetic energy of electrons. Using E equals hf, we can find the energy of a photon easily. Then using Einstein's photoelectric equation, we can find the maximum kinetic energy and the speed of photoelectrons. Example 6. Change of photoelectric current with frequency of light. When different colors of light have the same intensity, they have different numbers of photons per unit time hitting the cathode surface. In this question, the saturated photoelectric current is higher for blue light than for violet light due to a larger number of photons received by the cathode surface per unit time. On the other hand, the stopping potential depends on the maximum kinetic energy of photoelectrons, and thus larger for UV radiation, which has a higher frequency. The table on the next page summarizes how Einstein's photon model explains the observations in photoelectric effect experiment. Try check point 6.